Let's learn about E and ln. Why do lumberjacks make good musicians? Because of their natural logarithms. We're going to learn about what is E and ln. We'll learn the exponent rules that go with E, a new interest formula. We'll graph E, and then we'll do the log rules with ln as well as graphing ln. Let's get ready. You are going to need your calculator, notes, and pencils, and we'll have lots of new concepts. So first off, what is E? Remember our compound interest formula, and if we deposit $1 at a rate of 100%, which means that our R will also be 1 and our time will be 1. So we'll make everything 1. We'll go to 5 decimal places and we'll change the number of times that we compound. So with that $1, if we are compounding it annually, that means once a year. Biannually is twice a year. Monthly is 12 times. Weekly we'll go with 52. Daily is 365. 8,760 is hours, and 525,600 minutes, if you know that song. So that's if we did it every minute. So now let's take a look at this. So if I plug this in, all the ones, and I do that all out on my calculator, I get A to be 2. I change the number, so I'm only changing n to 2. I get 2.25. Change it to 12. So when we compound it 12 monthly, then we're at 2.61. Weekly, 2.69. Daily, 2.71. Big jump here to 8,000. Not a big jump here. Look at that. Not too much of a jump. And a huge jump, but still, those are very similar numbers. It doesn't matter what number you put in there, how fast you start compounding this. This is never going to reach 3. It's never even going to reach 2.72. So that is the number E. E is an irrational number. What does that mean? Irrational means that it goes on forever. It does not repeat. E is Euler's number, so it's pronounced like oil, Euler's number, and that's the number. So you can kind of think of it like pi. It's irrational. We have a symbol for it. We can call it 2.71 like we call it 3.14, but E is a new number. We're going to have a button on our calculator for it as well. The rules of exponents, all the same rules apply with the same base. So now our base is going to be E. So if I have E squared times E to the 3, my rule for exponents is if you have the same base and you're multiplying, you're just going to add the exponents. So you're not hitting this on your calculator to find out the value. You're just applying the rules of exponents. Here we have 2 is getting squared. This is a power raised to a power, so we're going to have 4e to the negative 2. We don't want to leave the negative exponent, so we'll do the reciprocal of just the e. The 4 is not getting that negative, and then it would simplify to 4 over e squared. Remember our old formula, we just looked at compounding a certain number of times. We saw that it doesn't matter how fast we get, we can even do it every minute, every second. So if we remove sort of that piece, a little bit of the n, and we put in our base of e, and now we put our rate up into the exponent. So our a is the ending amount, p is the beginning amount, e is our new number that we've looked at. Our rate is now up in the exponent with our t. This is going to be if we are compounding continuously. So you have to see that word continuously. And when you see that word, it knows that you want to use the formula with the E. If you deposit $1,000 at a rate of 5% for 6 years, compounding continuously, how much will you have? So we plug in the 1,000. E to the 0.05, we change our rate, and we're in for 6 years. So we have every number on the right-hand side. The E button is right above the LN button. So you want to hit second and then E, and you can calculate that, and you're going to get about $1,349.86 when you do that. Let's look at graphing E. So if we go back to exponentials, we remember that the A in the exponential is our y-intercept, our b is our base, and then it's b that determines if it's growth or decay. If it's bigger than 1, it's growth. If it's between 0 and 1, it's a decay. But now with e, we make e the base. So when e is the base, a is still the starting y-intercept. Now we have to look at b, which is in the exponent, and if it's positive, it's growth. If it's negative, it's decay. So we don't compare it to 1 anymore. We talk about positive and negative, so essentially comparing it to 0. And this is what the parent graph is going to look like. E is just another number. It is bigger than 1. It's an exponential, so we have the same y equals 0 asymptote. We have our y-intercept at 0, 1. And then this point here is 1. So if I plug in what x is, 1, then I'm getting y equals about, I should do the squiggly there, 2.71. And that's that point there. So that's comma E. If we put some more letters in here, A is still the starting y-intercept. E is our base. The sign of B will determine if it's growth or decay. Remember, it's not just H. If we do have a value of B, H divided by B is going to tell us our shift left or right, and K is going to be our shift up and down. The asymptote is normally going to start at y equals 0. Let's look at this graph and think about how we would do this. So this is going to go to the right 1 and up 2. Moves just like everything else. So my original y-intercept would have been at 0, 1. So I go to the right 1, up 2, and now I'm here. My original asymptote was down at 0, so that also shifts up. So it has an asymptote at y equals 2. My exponent is positive, so it is a growth, and we have that graph. Let's just investigate a negative exponent. So the negative, it's still going to go through 0, 1, but the negative is going to make it a decay, so it's now going to be falling. If we look at the green was our regular, the red is now, we shifted it up. So it has a 2 out in front, so that is my starting y-intercept, and that is my A, so it's vertically stretched. You can see the green was stretched up to be the red. And then if we go to the blue, so now we have less than 1. So that is our B, and that is a horizontal stretch. So we're pulling the blue one away from the red one. And then if B is bigger, so now it's going to be a horizontal compression. So I'm pulling the purple one away. Don't have to get too hung up on that. I just wanted to show you the negative exponent. So what is ln? And I wrote it in cursive. It is usually lowercase ln. I just didn't want it to look like in. It is the natural log, and it goes with our natural base of e. They go together, just like 10 and log base 10 go together, or 3 and log base 3 go together. They're going to be inverses of each other. So let's find out how that works. Remember, our first step in inverse is to switch the x and the y. So we'll switch those around. Now this is an exponent form, so I want to go to log form. My base is e. So I'm going to say log base e of x equals y. And that is just a little bit weird. So we're not really going to write log base e. Instead, we're going to write ln, lowercase ln. So natural log is the same thing as log base e. The graph of the natural log, it is a log, so it looks the same as a log graph. It has, the parent graph has an x-intercept of 1, 0, and it has a vertical asymptote at x equals 0. So let's take a look here. The red one is what we've already done, log base 2. You can see it has an x-intercept of 1, and then it goes through the point 2, 1 for log base 2. So then if I look at ln, thinking that it's log base e of x, it does still go through 1, 0. And now this point is e1. So let's see how that works. Log base e of e equals something. Well, e to the what is e? It's got to be 1. So we have that point. So it's just a slightly different there. It's going to shift the same way. So I would have started at 1, 1, 0. So I'm going to shift to the right 2 and up 3. I have a point there at 3, 3. I'm going to move my asymptote. It's going to go to the right 2. And let's check our point, make sure we did that right. So ln of 3 minus 2 and then plus 3. So ln of 1 and then plus 3. Well, ln of 1 is log base e of 1. So log base e of 1 equals something. E to the something equals 1. Well, that something can only be 0. So this whole thing is 0 plus 3 is 3. And then we have our log graph, so we're just going to draw it like that. And there you have it. Properties of logs, it's going to work the same because a natural log is a log. So when you have addition, you're going to condense it with multiplication. When you have subtraction, you'll condense it to division. And when you have something multiplied out in front, it's going to become the exponent. Vice versa, if you have multiplication, you're going to separate that into addition, division into subtraction, and then the exponent becomes multiplication out in front. Let's just try to expand this following those same rules. So I have 3 different variables. That means I'm going to have 3 ln's. So ln of x squared, but I'm going to bring the 2 out in front, plus ln of y minus 3 ln of z. Works the same way. So to recap E and ln, E is a new number for us. It's a base. Ln is a new logarithm that goes with it. It's the natural log. E is graphed like an exponential. Ln is graphed like a log. E follows the same exponent rules, and ln follows the same log rules. Nice job.